Hey everyone, thank you so much for joining in. So team, can you please confirm whether you're able to hear my voice and see my screen? Can you please respond me? Excellent guys. Thank you guys for confirming. I see confirmation from Aditya, Rakshit. Okay, Dheeraj is responding. Okay, thank you so much guys. So we are live on multiple platforms. So I think we are live on the YouTube channel of Manifold AI Learning. And you're also live on the authors page, that is my page, my LinkedIn page, guys. Okay, thank you so much everyone for taking your time and joining me on this live session. Now the topic of today's session is how we can package the machine learning model. That is, how do we take a machine learning model from our notebook to the production, that is how we can actually go ahead and perform the deployment. So that's what we are going to learn today. So when we talk about machine learning as a data scientist, or in a general way, what you are aware is will be writing the code in a IDE. It could be a Jupyter notebook or any such IDE. Now using that IDE, we'll go ahead and like perform the experiment on this given data set. So it's an iterative approach. First, we will select the data set, and once I select the data set, I'll go ahead and check the properties of my data set, followed by analyzing this given data set to understand the given data and the relationship that we have got. And once the analysis is completed, we would go ahead and apply the machine learning model which is suitable for the task and the data set depending on my output variable. So I can say whether it is an uh, regression or classification. If it is regression, I'll use the regression family classes, that is the models. If it is classification, I'll be going ahead and applying the classification based algorithms on the given data set. Now, once I apply it, we would go ahead and perform the hyperparameter tuning on the best models that we have got on the chosen model, which is the best performing model, and then we will deploy it. Now, the common thing that we say is, okay, once I've got the model, I'll go ahead and deploy it. Now, as we have seen in our previous live session, in order to go ahead and track those experiment, we have the various libraries like MLflow. So we've got a libraries like MLflow, which will help me to track the experiment. Now, what we'll be discussing today is, let us assume that you have a model. You have generated a model file on applying the analysis on a given data set. Now the question is, how do you package this machine learning model? So when I say machine learning model, it's not just the file that I've got. It also contains the software code, which we'll be using it to generate the prediction. So the question is, how do we package this machine learning model? That's what we'll be learning today. And we'll be taking a hands-on approach where we will take up a script where we have applied the machine learning on a given data set. And on top of that, we'll be going ahead and look into the other aspects of packaging the same. So let's go ahead and let's understand the same thing. Okay, so before we proceed with the today's agenda, just want to let you know. So if you want to be part of our future session, so subscribe to the YouTube channel of Manifold AI Learning. Let me take you through the YouTube page. So it's youtube.com/manifold AI learning. I highly recommend you to join this page, subscribe to our YouTube channel so that you get to be part of the future live session. And also follow us on LinkedIn so that you can also join the sessions through the LinkedIn as well. So here you can, yes, you can reach the instructor on uh, the LinkedIn as well. This is me, Nachiketh Murthy. So you can reach me on LinkedIn, where you can also be part of this live event through the LinkedIn as well. Okay, follow the Manifold AI Learning, and like you can also follow through the LinkedIn as well for the author as well as the Manifold AI Learning. All right, guys. Now that being said, so let's continue with the today's agenda. That is, how do we actually create the project structure for the machine learning project packaging? Now, as I mentioned, this would be a pure hands-on. So let's go ahead and let's see how we can package the machine learning model. So first and foremost, as I mentioned already, I cannot use the notebook interface when it comes to the packaging of the machine learning model. So the reason because here, uh, like uh, in our general scenario, okay. So when we are working with the notebook environment, okay, so we cannot take that notebook environment or the notebook itself in performing the prediction. We generally want to divide the overall activity that I'm doing into the sub modules. We call it as a modular programming. We'll apply the modular programming approach so that we'll divide the code that I have got into the separate file such that each file that I'll have will contain everything that is necessary to execute a defined piece of logic. And once it performs the activity, it can return the expected output. And we will ensure that these modules can be called by other files so that it would act as an input for them. So that's the overall idea about this module. So we will create multiple such modules. I'll say M1, M2, M3, M4, and so on. So I'll create multiple such module and I'll package it in a single package. I'll create it as a single package. So I'll combine multiple such modules into a single package so that whenever we are implementing this machine learning code, we'll be implementing it as a package. So we will learn how we can create this package structure. Okay, so that's the overall idea behind the same. Now let me just give you a brief idea about this package and the module. Now when I say module in Python, let me start my VS Code. Okay, so what I'm going to do is for today's session, I'll create a new GitHub repository. Packaging ML Live. Okay, that's the repository that I'll be creating. Perfect. So once I've created this repository, I'll be adding the files to this repository. So I'll open up the folder. Yep. So whatever the code that I'll be writing, it will be updating directly on the GitHub repository so that you can get the code right away from this GitHub repository. All right, guys. So let's get started. See, when I talk about any package, so package is nothing but creation of the Python script, and uh, we will load the programs or the functions or the variables from that Python script. Okay, that's the overall idea about this module. Now let me just give you an illustration as how to work with the module. So that will be a quick demo on the same so that you'll get a clear perspective. Okay, so let me launch an Anaconda Navigator so that it is easier for us to understand and follow along with me. Okay, so I'm going to launch the Jupyter Lab. So that would help me to show you in a clear manner, which is in a notebook fashion. So here, okay, so let us understand about the concept of packages. Like before we go to the packages, let's start by creating a module. A module in Python is basically a Python script. Let me give you an illustration. Suppose I've got a Python file which is hello.py. So this is my Python script. Now when I have got a Python script, I'll call it as a module. So the benefit of creation of this Python script is, suppose inside this Python script, I've got a variable as well as a function. I'll say my x is equal to 100. My x is a variable. And I also have a function which says as def print something. That's the function that I'm going to create. And this function is going to say return hello world. So I'm going to call this Python script as a module. Now the best part is once I have this Python script, I can actually import it in the other part of my program. Like for example, Okay, since you are most familiar with the Anaconda Jupyter Notebook environment, let me just go ahead and create a notebook. Now this notebook is present inside the same folder where this hello.py file is present. So I can now say this as import hello, which is my module name. Now when I say import hello, I'm able to import that Python script as a module. So I have imported this module itself, which is hello. Now then I can access the variables that are present inside this hello module. So I can say hello.x. This will return me the output as 100, and hello dot my function that is print something. I can execute this and this would give me the output from the function. That's the core concept of this module. Now let us assume we have got a package. Now, when I say package, package is nothing but it's a collection of modules. It contains one or more relevant modules such that they are interlinked with each other. And when I'm working, I can have a package which contains the sub package, and this sub package can hold the modules. So we treat it as a in the format of a file-based hierarchy. Okay, you can think of it as a file hierarchy of directories as well. Okay, that's the overall idea about this package and module. So I can say a package A. So I can say it as a package A, which is like a folder. Now inside this folder, I can have the sub package, which is nothing but the subdirectories. I'll say package B. Now I can say package B is a sub package of the package A. Now inside this package B, maybe I can have a Python script, let's say f1.py. Or inside this package B also, I may have some Python script f2.py and f3.py. So let me just show you how it actually look like if I'm creating something like that. So what I'll do is, so here I'll create a folder called package A. Inside this folder of package A, I'll create another subfolder B. Okay. Now inside this package B, I'll create a function that is called as f1.py. Now inside this f1.py, I'll just create a dummy function. I'll say def print something. That's what I'll mention, and I'll return as output from f1 module. Okay. Now inside this package A folder, I'll create two more files. So I'll say f2.py. So I'll copy it from the reference of the f1.py file, and I'll say output from f2 module, and I'll also create one more Python script. I'll say f3.py, and this is the output from f3 module. So basically I've created the hierarchical placement of files as I've described right now on the screen. So when I have this folder structure, now if I want to import this f1.py, that is f1 module in my code, the way that I would import is I'll say from package A dot package B, I'll be importing my f1 module. Now I can say f1 dot print something. See, this would go ahead and return the output from that f1 module. Now if I want to import this f2 module, then I'll simply have to say from package A import f2. So this would import my f2 guys. See, this would import my f2. So I'll say f2 dot print something. So this would import the f2. That's the overall way in which we would work, okay, whenever we are working with the package and the modules. So in the old version of Python, so we actually had to create underscore underscore init underscore underscore file. So just to ensure that we treat it as a package. So with the latest version, it's not mandatory. So if you want to ensure that your package that you're creating is backwards compatible, you can go ahead and follow it in that way. That's purely optional, that I would leave it up to you. Okay, so this is about the idea of package and the module. All right, guys. So are you with me till here? Any questions? Do let me know. I'll give you a few seconds so I can see a lot of learners over here, and thank you guys for asking a lot of questions. Like, I hope I have answered on the fly while I was explaining you. So if you have got any questions, do let me know. If you're clear, please confirm by typing as all good. Okay, thank you, Dheeraj. Thank you, Sridhar. Okay, thank you, Kavya. Thank you, Ramya. Thank you, I think it's Saumya. Okay, what about others? Is it clear? Please confirm by typing as all good. Thank you, Samiksha. Okay, thanks a lot, folks. So, for responding and confirming that you are with me till now. That's good to know. Okay, so now let us proceed ahead and let's think about as how we can modularize, okay? How we can modularize the overall code, especially the machine learning implementation. Okay, so in order to do this, so what we will do is we will take up an example implementation. So one of the example implementation that I'm going to take is I think there is one which we have created in the last session. I think that's about ML flow demo. Okay, we'll take up this train.py file and we'll try to modularize the same so that you'll get a better idea as how do we actually modularize everything. So what I'm going to do is, so for the demonstration, I'll create a new folder itself. I'll say wine prediction. Now inside this wine prediction folder, I'll create a file which is my train.py file. So inside this train.py file, so just observe, I'll just remove the references to the ML flow because we are not much focused as of now about the ML flow in today's session. We are basically interested in packaging. Okay, so okay, so what we have done in the last session is we have let me just clear out few things so that it is easier for you to follow along, which is specifically to our today's requirement. Okay, so this is a basic implementation. What I have done is, in this case, there's a train.py file is present. Inside this train.python script file, I'm importing the necessary libraries, NumPy, Pandas, and I'm actually working with a regression-based task, which is wine quality data set. So we will load the data set from a GitHub repository. We'll split the data set into two parts using train test split, and we are going to display some metrics. So when someone runs this Python script, here this is going to load the data set from this URL, and then we will read that CSV file. Okay, then after that we will separate the X and Y, and once that is done, we will split the data into two parts using train test split function, and then there are some values that we have instantiated right here, that is alpha and L1 ratio, and we are implementing the model and we'll perform the fit and we are generating the prediction. Okay, finally we are returning the metrics. So this is our code and this is how it would look like. Now, what I'm going to do is when I say modularization, so in case of modularization, it is basically splitting whatever you see right here, splitting whatever you see right here in terms of the individual module. So one common thing that we do whenever we are working is we want to separate the configurations and the code. That means whatever the manual configuration that I had placed right here, that is alpha, L1 ratio, maybe the file name, okay, that is a file address. So all those manual configuration that we have mentioned right here, we will separate it in a separate module itself. To illustrate the same, I'll create a new folder called config. So you can think of it as a sub package. So if wine prediction itself is a package, then this config folder will be acting like a sub package. Now inside this config folder, I'll create a file which I'll call it as config.py, which means this is a module that I'm creating. Okay. Now inside this module, I can now go ahead and like write the configuration. Now, when we are working with any environment, if I want to save any file or if I want to do anything, so to ensure that that particular path is repeatable, we have to get its root path or where exactly that we have to refer, because this configuration file is present in one location, my training file will be other location. So we should be able to get all those path as well. So what I'll do is I'll start by importing the necessary libraries. First thing I'll do is I'll import the pathlib and I'll import the OS, which will help me to work with the files and directories. And along with that, I'll also import wine prediction, which is basically this uh, this model itself, that this package itself, where exactly this configuration is present. Now, first, what we need is the location, the root directory where my model is present. So what I'll do is I'll say package root, and I'll get the package root by writing as pathlib dot path. Okay, and I would go ahead and get this particular parent. Okay, if like let us suppose that this is my prediction model. Okay, I'll get its parent for it in case like if I want to get its package root. So I'll say my wine prediction, which is my uh, cla package that I've got. I'll say underscore underscore file underscore underscore. I'll say dot resolve, and on top of this I'll say parent. So let me just illustrate what is happening with a very simple example. See, I've created a package A, right? So suppose I'll show you. Okay, import package A. Now when I say package A dot, okay, so what I have mentioned in the code right here, so I've mentioned as underscore underscore file. So what happens if I call that uh, syntax? Okay, let's see. uh, Okay, so when I generally call the file, so what it does is it will return the place where I have the init file is present. Okay, so in my case, I do not have an init file, that is init underscore underscore init underscore underscore dot py file. Hence, it is returning it as none. Let me just illustrate it because this is important for me. So I'll say underscore underscore init underscore in underscore dot py. Okay, it's a blank Python file. Okay, now I'll just execute this. Let me just show you guys. Think, okay, let me add one more file right here. Okay, so it's up. So, okay, I think I missed few things. So I'll have to import the pathlib. I think that is something that I had missed. So I had to import the pathlib. Now, once I import the pathlib, then I can say pathlib dot path. Okay, then I'll have to send in this package A and I'll have to mention it. Okay, let's see what do we have. Okay, pathlib dot path prediction underscore model dot resolve dot parent. Okay, I think this is what I had mentioned. Okay, Okay, let's have a look into it at a later point, team. So I think there seems to be some error, or maybe I'm missing out something. But yeah, let's continue with our coding. I think once the issue is fixed, maybe we'll fix it at a later point as well. That's still fine. Okay, so first I'll get the uh, parent location, or the package root. Okay, once I get the package root, so whatever the folder structure, this would generally give me as, okay, where exactly my root directory is present of this current package that we are working with. Okay, then what we did in the strain.py is we have also mentioned the URL. So instead of writing it over there, I'm going to note it down here in this way. I'll say dataset.url, and for this dataset.url, I'm going to mention the URL which we had mentioned earlier. Okay, so in this way, I'm going to note down this URL. Okay, now apart from that, what are the other things that we are doing? So here, what we have noted is we have noted that the column name of the target variable is quality. So I'm going to create as another variable that is target, that is uh, target, and I'll mention the target as quality. Okay, that's what I would note down for the target. That is what is present right here. See, what I have done is I have manually mentioned as quality in the target variable. Okay, so instead of manually mentioning over there, I'm just trying to note down in this configuration file. Okay, now apart from that, what are we noting down? So we are noting down the alpha. So I'm going to say alpha is equal to, we can manually assign the value over here, 0.7. Then L1 ratio. So I'll say L1 underscore ratio, and I would say this as 0.4. Okay, and then what are the other things that we are doing? I think these are the few things that I'm doing right now, guys. Okay, so these are the few things that I'm doing, or maybe, yeah, test size. Okay, maybe we can also note down this test size. I'm going to say my test size is equal to 0.3. And even the random seed, even also we can do this as well. Okay, I'm just giving you an illustration as how we can actually do it. So whatever the values that I'm using inside this uh, train.py file, in this training module, okay, I'm trying to note down in this configuration. Now the way that I'll be using and referring this in my training script is, so I'll say from config, uh, the way that we would generally mention it is in this format. Okay, from wine prediction dot config, I'm going to import the module name, that is config. Now wherever I want to return the value, see, instead of mentioning my CSV URL over here, I'll show you how I would do it. I'll simply say config dot my dataset URL. Okay, next, for separating the uh, X and Y, okay, instead of saying columns as quality, now I'll mention this as config dot target. Okay, that's what I'm doing. So I can directly mention it in this format. As you can clearly see, I'm storing all those values that could change in a separate module. Next, in the train test split function, okay, so I've written as x comma y, and train test size is 0.3. Instead of test size, I can say config dot test underscore size. And instead of random underscore state as 0, I can simply say config dot random underscore state. Okay, and instead of alpha as 0.7, I can say config dot alpha. And then instead of L1 ratio as 0.4, this time I can say this as config dot my L1 ratio. Okay, so in this way, we can separate everything. Whatever the manual instantiation that I'm doing, I can place it in a separate file. Now, if I want to change something, so I can go ahead and modify in this file so that whenever something is used, like when these values are changed, so when I call this stain.py file, these values will be picked. So let's go ahead and see if you are able to execute it. Okay, so let's go ahead and check out the same thing. Now, what I have to do is, since this wine underscore prediction is not present inside the same folder where I have this config.py is present, what I have to do is I'll have to add this particular path as my Python path. Now, when you're working in Mac OS, so what you will do is you will have to add it. Let me just show you the exact place where you need to actually do it. So here, open up your terminal. I'll say dot slash bash underscore profile. So I'll have to modify this bash underscore profile, guys. So open your Finder. So once you go inside the Finder, go to a specific folder. Uh, yeah, dot bash underscore profile. So inside this, just open this bash underscore profile. Okay. Now here, what you need to do is you'll have to export. Okay, you'll have to mention the path where you have to actually where you want the system to focus. Okay, you'll say Python path and you'll set it equal to the location where your folder is present. In my case, okay, in my case, so yep, it is my author repository. Okay, under this author repository, this is the folder. Okay, specifically the wine prediction. So I'll just go ahead and mention this folder path. So in order to get the same, let's see if it allows. I'll say copy path. I'll just add the same. Okay, so I'll just mention the high level folder path right here. Okay, just update it, and once you have done the update, I think we'll just have to go ahead and call the same. So the way that you will do is, okay, just a few seconds, Tim. There are a few more questions. Okay, the way that we will reload that file is we'll simply say source slash dot bash underscore profile. Okay, so this should help me to load that particular path. Okay, now which is my new Python script, a new Python path. Now let's see if it works. Okay, since I'm inside that folder, I'll call Python and I'll try to import the folder structure that I've got. In my case, wine underscore prediction. Okay, so if I'm able to import it, so that means that I'm able to execute it without any issue. Okay, so ensure that you add this to your Python path. Okay, ensure that you add this to your Python path. If you're working in Mac OS, you have to update this bash underscore profile file. Okay, that's something that you have to note down. Now, if you're working in Windows operating system, you'll have to go to the environment variables, and inside that environment variables, just add the folder location where you're trying to create your machine learning model over there. Just mention that path over there under that Python path. Okay, that's a prerequisite if you want to load this custom module, because we have not installed it So that's the reason we have to load it in this way. Okay, let's come back. Uh, yeah. So what we have done is we have mentioned this wine prediction, and we have the Python script file. So let's see if we are able to run this Python script file. So I'll say cd, I'll go inside this folder of wine prediction, and I'm going to run this Python file, that is train.py. So now, okay, yeah, I think there are some typo. Let me fix that typo. So instead of uh, this should be in camel case. Okay, it looks to be few issues that we have got. Let me do one thing. So to fix this, what I'm going to do is inside this wine prediction folder, I'll create a, fi a file that is underscore underscore init underscore underscore init dot py file, and I'll also create it inside the config as well. I think this should fix. Okay, now let's see. All right, excellent, guys. So I think it was since I was trying to load something first, it was trying to fetch the file, that is the init file location. Since it was not present, it was giving the output as none, and that is the reason that we got the error. Now, once I ensured that there is an init file is present, so I'm able to proceed. Now, what it says is it is unable to find the random underscore state. So let's see if we have written it correctly inside our configuration file. So here it is random underscore seed. Okay, so it's a typo again. So we'll just fix this. Now let's rerun this train.py. So I'll say Python train.py. So now what it says is I've got the output. So the output says that my RMSE is 0.72, mean absolute error is 0.5950, and R2 is 0.131. So what I showed you right now is a high level way in which how I can go ahead and separate the manual instantiation into a separate module, that's a configuration module. Okay, now we'll continue further and we'll go ahead and do some other stuff as well. Now, let us assume, okay, so instead of defining my evaluation metrics over here, let us say I want to place it inside a separate module itself. Okay, maybe for some specific reason you are working in a complex project, and now being inside this complex project, so you have your own set of evaluation metrics which you have created, which are the custom evaluation metric. Now in that case, so you should be like you want it to be equal to, you want to be placed in a separate module. That's also a common practice that we do. So what I'll do is, so I'll create a separate module. Okay. Now I'll create a module called eval.py. That's a Python module that I'll create. Now inside this, I'll go ahead and place this function. Okay. Now, in order to do this, I'll have to do some import as well. So I'll place this import right here. Okay. So what this evaluation metrics function is receiving, it is receiving y-test and y-pred, and this is going to return the RMSE, MAE, and R2. So now, if this is the case, then the way the in my code is going to work is the way I would work is in this way. So I'm going to say from wine prediction dot eval. Okay, I'll have to import this evaluation metrics. So that is how I'll be importing this evaluation metrics function. So if I come down right now, see, I'm calling this evaluation metrics function. Now, if I'm calling this evaluation metrics function, This will be calling different module itself, which is present inside this wine underscore prediction folder. And there it will be executed and we'll get the output. Okay, I've separated this evaluation metric as well. Now in this case, I have directly went ahead and performed the fit. Now let us assume that we have some pre-processing activity that needs to be done. Now in such cases, generally, we'll also create some data pre-processing activity as well. So we'll create it as a separate like sub package, and that sub package is what we do it for loading the data set as well as loading my model as well as the saving the pipeline. Let me just illustrate it with an example. So what I'll do is I'll create a new folder. So here I'll call the folder as processing. Inside this folder of processing, I'll create two new modules. One is for data handling, and the other one I'll call it as the pre-processing. Here, inside this data handling, I'll create the functions in this way. Okay, so I'll just mention it as import OS, and from prediction, that is my wine prediction dot config, I'll be importing my config module. Okay, now what I'll do, I'll create a separate function for loading my data set. Okay, so I'll just say load data set, and here inside this load data set, I'll say URL is equal to config dot I'll get the variable name. What is it? It is actually config dot dataset URL. Okay, config dot dataset dot URL. Then I'm going to say data is equal to pd dot read underscore csv, and we will mention that URL, and separator is equal to this. This is as per my given data set. Then what this is going to do, this is going to return the data. So that means I have changed a little bit now. So I'll have to accommodate it in my train.py file. So now since I want to load the data set, the way that I would mention it is in this format. From wine prediction dot processing, I'll be importing data handling. I'll also import the pre-processing module. Even though I'm not written anything, I'll just import it for now. Okay, now here, instead of directly loading the data set, so the way that I'm going to modify is, I'll just say my data is equal to data handling dot load underscore data set. Okay, so when I say data handling dot load underscore data set, this function will be called and the data will be returned as a pandas data frame. Okay, I've modularized the loading the data set in a separate data handling. So to ensure that it works smoothly, I'll also create a dummy and like underscore underscore init underscore underscore dot py file over here inside the sub folder as well to ensure that it works perfectly without any issues. Okay, now maybe inside this data handling, I'll also go ahead and perform the serialization. So when I say serialization, it's about saving the model. So I'll say save underscore model, and I'll get the model to save, which is the model object that I'll get as an input. So I'll get the save path. So to get the save path, okay, so way that I'll do is, okay, instead of me manually saying, I'll define it inside my configuration file where I would mention as model name is equal to, I'll I'll say wine model dot pkl. That's the model name that I'm going to use it for saving. So here, when it comes to the save model, I'll say save path is equal to os dot path dot join. I'll be joining the config dot. Uh, let's do one thing. Yeah. So I'll create one more thing, guys. Okay. The way, let's do one thing. I think let's try to create the folder structure itself. I'll see if I can modify something. Okay, so what I'll do is instead of storing it in the processing folder, I'll create a folder called, okay, so I'll be placing it inside the wine prediction folder. I'll say trained models folder. Okay, we'll be saving it inside the trained models folder. Okay, so what I'm going to do is to ensure that it works correctly, I'll note down this path. So instead of saying it as model name, yeah, we'll keep the model name. I'll also say save model path, and this save model path is given by os.path.join. So what is it that I'll be joining? I'll be joining my package root. Okay, I'll be joining my package root as well as the folder that is trained models. So I'm saying where exactly my model should be saved. The model should be saved inside the trained models folder. This I'm calling it as save model path. So now when it comes to the data handling script, I'll say path.join config.save model path, comma, config dot I think that's the model name. Okay, let us validate it here. Yeah, it's a model name. So inside that folder, go ahead and save it as the name of this model name. Okay, that is what I'm saying right here. All right, guys. So I'll take a pause here. So are you able to follow along with me? Okay, thank you, Mrityunjay. I see the Mrityunjay says explanation is crisp and clear. Thank you, Mrityunjay. Diksha says, sir, it is really helpful. I'm learning a lot. Thank you, Diksha. Okay, Rakesh says Friday also sessions. Yes, Rakesh, I hope you are enjoying. Okay, so Dheeraj, okay, sir, no questions as of now. It's a great. Now I'm able to learn the package. Okay, thank you, Dheeraj. Okay, what about others? Any questions, team? So please confirm by typing as all good if you do not have any further questions. Okay, that's great, guys. So I see few more confirmations pouring in, like Manjunath, I think Kavya, Lata, Ramesh, Samiksha, okay, Samuel. Excellent. Thank you so much, guys, for confirming. All right. So what we have seen is, so we have defined the saved model path. Okay. How does the model to be saved? And we have defined it over here. So I'll say this save model. Okay. Now, okay, and then, okay, there are a few more questions. Okay, let me just take that. Okay, yeah. So let me complete it and then I'll take up the question. So Money has asked the question. We'll take up once I complete this. Okay, so I have defined my saved path. Now, what I'll do is, in order to save the model, I'll say import joblib. Okay, and I can say joblib dot dump, and I'll be saving the model. Okay, and where I'll be saving? I'll be saving in the save path. Okay, and once I have saved it, I'll just print the message that says as model has been saved successfully. Okay, under the path, and I'll mention this save path. Okay, this is the output that I would mention, guys. Okay, this is the save model path. Now once this is done, so I I'm hoping that you're able to follow along. So what I did was I've created a function which is a save model function, which is going to uh, help me uh, to save it in the specific path. Okay, now let me just go ahead implement it in our train.py. So here, what I'm doing is I'll perform the training. Once I perform the training, so I'll say a data handling dot, okay. So it's the function name that I've got is save underscore model. And here I'll mention the model that is LR. Okay, this will perform the saving inside this uh, train model path. Okay, that's great. So we have performed the saving. Now what we will do is, okay, I'll also write a function for deserialization. Let me just complete that. Okay, so I'll perform the deserialization as well. So when I say deserialization, so it is basically loading the model. Okay, I'll basically load the model. Okay, so when I say load the model, I'll just keep it in this way. I'll just keep the, uh, I'll say model to load. Okay, instead of save, I'll say model to load. Okay, then here my load path is given by os.path.join config.save model, comma config.model name. Okay, this is what I would get. Okay, this is going to load the model. So in this case, so basically, uh, it is this, okay, model to load. So I'll say correct one is model name to load. Okay, then instead of dump, I'll say joblib.load, and I'll be loading from the load path. And what is it? This is my loaded model. And what this is going to return? This is going to return my loaded model. Okay, so once I have saved the model, the way that I would do is I'm going to load the model. So I'll say uh, final model is equal to data handling dot load underscore model, and inside the parenthesis I'm going to mention the model name. So config dot, so I'll just have to mention the model name from my configuration file. So that is config dot model underscore name. Okay, so in this way I'm going to load the model. Now once I load the model, on this model that I've loaded, maybe I'll generate the prediction. Okay, so I have performed the serialization as well as the deserialization. Okay, so this is what I have done. Now, there's a question that I've got, which is an excellent question, which is a common question from every data scientist. The question from Mani says is, if I'm going to write every model code, including the processing data handling with the Python project, managing it using the VS code in this case, what is the role of Jupyter Notebook? Now, if I'm using a modular structure approach, so like how is it helpful? Well, so here, the stage that I'm in right now is packaging my ML model, which means at this point of time, I know already about my experimentation. That means I've already done the experimentation. I've done the experimentation. I have already decided that what kind of pre-processing that I want to do on this given data set. Okay, and I'm already aware that what are the model parameters that I want to use, and I'm already aware that, okay, what exactly is the hyperparameters that I want to use it to get the best model. Okay, so after the experimentation phase, when it comes to the deployment, so I cannot package my Jupyter notebook and place it somewhere. So if I create this as a package, so I can go ahead and uh, install that particular package. Now let me just give you an example. So since it's a very common question that most of the learners ask, I'll take you an example. Let's say there is a model that I've got with me. So this model is the prediction model. Now, when I've got this model, when I have pushed it to this GitHub repository, if I want to install this model, okay, I just have to run the command as pip install and mention this GitHub repository. This will be installed as a package inside my environment. So to clarify this, okay, to clarify this, let me show you, okay? Since it's a common question, so I'll just go ahead and create a new environment. So Conda, maybe we'll create a new environment, virtual environment. Okay, so Conda, create new environment. We'll follow the instructions. So the command is simply like this. I'll just use this example. Okay, so here I'll say conda create and I'll mention the name as pred underscore model. That's the new environment that I'm going to create, and I'll use the Python 3.10. And yeah, I'll instantiate this new environment. Okay, then I'll go ahead and activate the same. Now I'll show you one thing. So inside this environment, if I now say Python and import prediction underscore model, it says there's no module named prediction underscore model. Now what I'm going to do, so being in this location, being in this environment of pred model, I'm going to install the model package which I had already created earlier for a different case. So I'll just run the command of this pip install git, and I'll be loading this package from the GitHub. So this is my custom package. So now I'll say install and install this package. So what this is going to do is this is going to install my machine learning model that I have actually created. So there is a machine learning model. This is actually a model package, which is a prediction model. Now, if I take you through this package of this prediction model, it basically contains its own configuration Python script, which is very much similar to what we are doing. It contains some data set. It contains the pipeline. It contains the prediction. And under this processing, it also has some data process, data handling, pre-processing. And along with that, it also has a function or sorry, module for the training pipeline. So this is implemented on a classification data set. And if I take you through this, uh, yeah, training underscore pipeline file. Okay, so here basically it is written in a modular structure. If I call this training underscore pipeline, then at that time it would simply go ahead and perform the activity of training. Okay, now let me do one thing. So instead of doing it in this way, in the command line interface itself, I'll say import prediction underscore model now, since I've installed the package. Now I'll say from prediction underscore model, I'll be dot training underscore pipeline. I'm going to import uh, perform training. Okay, I think there's a typo. I'll get an error. Training underscore pipeline. It is perform underscore training. Yeah. Okay. Now once I've imported it, if I just call this function, it says my model has been saved. So what it ensured is that when I installed this as a package, it ensured that the environment that I now have, it has got the same type of or the same version of the packages that I've used during the model training. That is by the NumPy specific version, Panda specific version, Joblik specific version. Everything is maintained over here inside this requirements.txt file. Okay, it is, I think, let, okay, in my case, yeah, it is maintained over here inside this requirements.txt file. Now to enable everything, to install it as a package, when I say pip install and mention that package name, see, I've written the complete package information over here in the setup.py file. So as you can clearly see, experimentation is very much important. Now, what we are talking about is how you can take your experimentation to the production. Now, in order to take your experimentation to the production environment, not only you have to take care of the not only you have to take care of your experimented models, but you also have to ensure that you create a pipeline and you have a flexibility to modify the values and to track those changes. Now that I have created in a modular structure, it is easier for me to check something if something is broken. Like for example, I can use this model as a pack, like I can use this package over here, okay, which is my prediction model. Let's say this is my package that I've got. Now I can place it inside my GitHub repository. Now for this GitHub repository, I can go ahead and generate the webhooks. I can configure a webhook over here, and if any changes happens to my repository, that means if I update my source code or if there is a change in dataset, using this webhook, I can actually trigger my continuous integration tool, let's say Jenkins. I'm going to trigger my Jenkins, and this Jenkins is going to get the latest package of this machine learning model and then trains it. That means it will perform the build first to see everything is working or not by making use of the Docker environment. And then once I perform the build, I would go ahead and perform the training to see if it is already working. That is, the continuous training would happen. Then once the continuous training would happen, then on top of that, I can conduct the testing with the help of the various modules like Pydantic or any such libraries to conduct the testing on that training that I've just performed. If it is working successfully, if I'm satisfied with the result, then I can go ahead and perform the continuous deployment. That means I can deploy it to a web service. Now to implement this CI, CD and CD pipeline, it's very difficult to do it with the notebook interface. And that's the reason when we think about production analyzing it, at the end of the experimentation, as a machine learning engineer, we think about modularizing the code so that we can perform the MLOps on top of it. So what we have done in this today's session is, guys, so we have seen the importance of modularization, and along with that, so we have actually performed the modularization from our code, like from our perspective about the example data that we have got. We try to modularize the same. Now, what are the next steps that you can do to complete this overall package building? Well, to complete the overall package building, so you have to go ahead and let me just show. I'll share you one more. I'll share you this. Just go to the repository link, guys. Okay. If you go to the repository of Manifold AI Learning, there is a prediction underscore model. You can refer this package. You'll get some idea. You'll have to prepare a manifest file and create the setup.py file. You can take these two files as a reference. Okay. And then you can implement it at your end. And once you have done that, you'll have to just go ahead and run some basic command that is for building that package. And like once you build that package, so you can push it to your GitHub repository and you can also try installing in your virtual environment as well. So once you create it as a package, so this overall folder structure will be referred to it and you don't have to worry about specifying the folder structure of the module. Okay, that's the overall idea of this packaging of the machine learning models. So this was about packaging of the machine learning models for the production environment, guys. I hope you guys have enjoyed this hands-on session. Now, if you're hungry for more MLOps in action, there's a course by Manifold AI Learning. So let me just share you the link over. Just check out the link. I'll share you the link in the chat window at a later point, team. Okay. So let's see if I can share it right away. So here, okay, I've shared you the link in the YouTube live chat, and I'll also share it on the LinkedIn chat as well, so that you'll have it as a reference. Go ahead, chat window at a later point, go ahead and Use the link and join this course on mastering the practical MLOps for data scientists and DevOps on AWS. So if you're hungry for more practical MLOps action, I would highly recommend you to check out this course. And yeah, more than 1,000 learners are actually enjoying this course, even though it's a very new one. So it has got more than 28 hours of the video content, which takes you through the complete hands-on as how to work in the cloud environment, especially of this AWS, and implement the ML ops. All right, guys. So with this, we come to the end of today's session. So I'll upload the today's code as well in the GitHub repository so that you'll be able to refer it under the uh, link, that is our repository link of this package ML Live. I'll be sharing you this repository in the chat of this LinkedIn as well as the YouTube. Okay. So folks, I hope you enjoyed today's session. Now, if you have got any questions, please let me know. If you're clear, please confirm by typing as all good. And I look forward to seeing you next time. So thanks again, guys. So thank you, Ranjit. Okay, I'm glad, Samiksha. Okay. Okay, I'm glad. Okay, that's great, Sridhar. So I'm glad that you found it helpful. Thank you, Rajitesh. Thank you, Divyansh. Okay, thank you, Divya. Thank you, Sharma. Okay, thank you, Patak. Okay, thank you so much, guys. I hope to see you next time. Take care and follow the page of Manifold AI Learning to get to know about the upcoming live sessions. I'll see you next time.